Good day. We are the group of conveyors here to present our final output. Our members are Eliza Baliesa, Kate Yene Carriazo, William Jefferson Onya, and Jade Vasquez. For the first problem, we have profit maximization using the graphical method. It says here that a manufacturer needs help in choosing how many units of STD or DEL dryers they need to produce. So the first step in profit maximization is to set up the objective function and constraints in mathematical format. To do this, we would need to identify our decision variable, problem objective, and constraints. For the decision variable, we have STD as our x and DEL as our y. The problem objective is to maximize profit. To put it in mathematical terms, maximize z is equal to 125x plus 110y. Here on the screen, you can see in tabular form are the 5 constraints that we need. Next slide. So the second step is to plot each of the constraints in a graphical format. Here are the graphs for the coordinates of the constraints. So here we have our constraints. The first is the SNP, the second is the motor, and the STD control graphs. Next slide. The fourth one is for the DEL control, and the last one is the ANP coordinates. Next slide. So the final graph will look like this, given all the constraints are plotted in it. The third step in profit maximization is to identify the feasible solution space. In profit maximization, we get the feasible area from the smallest lower left-hand corner in the graph, which is, in this case, the highlighted area here. So there are 6 corner points identified. Each of these corner points' coordinates will be then substituted to the problem objective in order to get the optimal solution. In this case, the most optimal solution is the 6 corner point, which is at x equal to 1,400 and y is equal to 0. To conclude, the manufacturer must produce 1,400 units of STD dryer type to maximize their profit to 175,000. Moving on to the next problem.
For the cost minimization problem, the question is how many cubic yards of each food should the farmer blend to meet the minimum chemical requirements at a minimal cost? What is the cost? So we made a table of the given data from the problem. Our objective function is to minimize C is equal to 30x plus 25y. Our decision variable is let x be the quantity of plant food mix A and let y be the quantity of plant food mix B. We then identified our constraints, which are for the phosphoric acid, nitrogen, and potash, including the non-negativity xy, and then substitute each of these to be able to get values of point A and B coordinates. We have shown here the point coordinates of each chemical requirement, as well as the graphs that we have after plotting all the coordinates. So after plotting all the coordinates, we have identified the feasible space and started to look for the optimal solution, which was done by using the objective function formula to substitute with the value of our corner points, which is from the constraint potash. So we found that there should be 46 cubic yards of each food to meet the minimum chemical requirement at a minimal cost amounting to 1,380.
For transportation model, the problem says that BOM Manufacturing has 3 plants, P1, P2, and P3, that all have retail shops B1, B2, B3, and B4. This table shows us the shipping fee for each plant and their respective retail shops. Next slide, please. BOM Manufacturing wanted to build a new plant from these 2 locations with this respective shipping fee or cost. Since the total demand is 3,100, it implies that the capacity should have an equal value of 3,100 as well. The difference of the demand and capacity will be 500, which will be the new plant capacity. Next slide, please. In this table, where the location 1 is shipping cost is added to the overall table with shipping costs of 6, 6, 4, and 7 from B1 to B4 respectively. Next slide, please. On the other hand, this is the table where the location to shipping cost is added to the overall table with the shipping cost of 4, 5, 8, and 4 from B1 to B4 respectively. Next slide, please. By comparing the total cost of location 1 and location 2, BOM Manufacturing must choose location 1 with 6,647 of transportation costs for B1, B2, and B4 for building a new plant because it only costs $12,100. Next slide, please. For portfolio management, the problem asks us to determine the best allocation of the available capital of $40 million, which will yield the highest possible investment gain. Next slide, please. So we have here the table showing the 5 types of investment where we can allocate the capital of $40 million. These types of investment will serve as our decision variables, labeling them as X1, X2, X3, X4, and X5 respectively. Along with this are the data about the annual growth rate and probability of losses. In addition, we also decided to compute the probability of gain for the sake of making the computation easier. So next slide, please. So it is important to identify our objective function formula, which can be solved using the formula of expected growth from good investments minus expected losses from bad investments. Next slide, please. Upon the identification of our objective function, we analyze the mentioned constraint, which include the following. So next slide, please. So the solution for the identified constraints are displayed in this slide for constraint 1 to constraint 5. So next slide, please. Since we already identified the necessary information, we were able to determine the possible allocation of $40 million investment by the use of Excel solver. So the optimal solution is to invest in balance and bonds investment with the amount of $16 million and $24 million respectively. The initial investment of $40 million will gain us a profit of $785,600. That will be all. Thank you for listening.